Hello, my name is Sanjuan. I work in the food technology department from the Universitat Politècnica de Valencia in Spain, and together with some colleagues from the same university and also one colleague from AINIA Research Center, we have developed this study entitled Optimization of the Pasteurization Process, Simulation of Food Temperature Evolution inside a Plate Heat Exchanger. Gazpacho is a cold soup made of raw blended vegetables typical from South Spain, although nowadays you can find everywhere in the country, in our country. This gazpacho soup was traditionally homemade, but in the last two decades, the processed gazpacho obtained by pasteurization of these raw blended vegetables is gaining importance. And for instance, the total sales of this product in 2018 amounted around 64 million liters. As I told you, processed gazpacho is based on the pasteurization of the product that is applied in order to increase or to extend the shelf life of the product. So the pasteurization of liquid foods is of essential importance in the food industry, and plate heat exchangers are a compact and efficient solution adapted to a wide range of products. To optimize the pasteurization process of liquid foods in general, that of gazpacho in particular, we need to model the process and also to specify the objective pursued. Thus, the goal of this study was to develop a mathematical model to describe the evolution of a liquid food, gazpacho, temperature inside a plate heat exchanger and to optimize the process under two criteria, namely product quality and energy consumption. Now I'm going to show you the materials and methods used in this study. As I told you, we wanted to process gazpacho andaluz, so we blended all grinded all the raw materials in our lab. These raw materials or ingredients are mainly tomato, but also cucumber, onion, capsicum, garlic, stale bread, olive oil, wine, vinegar, water, and salt. Then, once we had this raw gazpacho, we had to pasteurize the product in order to extend the shelf life, as I told you before. So we use a pilot heat exchanger working at counterflow. Here we can see a flow diagram of the heat exchanger, in which we can distinguish three sections: the recovery section, in which the raw gazpacho is preheated by using changing the heat of the already processed or already pasteurized gazpacho. Then this preheat gazpacho goes to the heating section, in which it exchanges heat with the steam in order to reach the pasteurization temperature, and then the gazpacho goes to the holding section, in which this pasteurization temperature is held for a predetermined time in order to pasteurize, to reach the pasteurization objective. So we also studied some quality parameters, mainly vitamin C, but also color, viscosity, pH, and we wanted to know how the heating treatment, the different temperatures or pasteurization temperatures affected these quality parameters. As I told you, in order to develop the optimization problem, we need first to develop the mathematical model of the process. This mathematical model was based on mass and energy balances on a control volume of a plate heat exchanger. And we solved the model by using MATLAB. So this allows us to simulate the pasteurization process in the heat exchanger. Then, as I told you, we wanted to optimize the the pasteurization, and we tackle this optimization problem under 2 points of view. So we have 2 optimization problems. The first one aimed at minimizing the effect of the heat treatment on the quality of the product. And we choose the vitamin C content as the quality parameter to be optimized. So the idea, as we can see here in this objective function, was to increase the vitamin C content at a predetermined pasteurization temperature in the 3 sections of the heat exchanger. Sorry. And then in the second optimization problem, problem 2, the aim was to minimize the steam consumption, because the steam consumption is not only important from the economic point of view, to decrease the cost of the process, but also to decrease the environmental impact of the pasteurization process. So our objective function aimed to decrease this ratio, the steam flow per kilogram of Gazpacho flow. Now I'm going to show you the main results of the study. Here we can see the model in a small section of the heat exchanger. That this model was solved by using MATLAB, as I told you, and in these diagrams, in these plots, we can see the simulation of the temperature of the 2 fluids, the steam and the cold fluid, which was the Gazpacho. And as regards the optimization, here we can see part of the results for the 2 optimization problems. We can see that the residence time of the Gazpacho in the holding temperature section was 12, nearly 13 seconds for the first problem, and the pasteurization temperature was 89.5 degrees. In the second problem, the heating temperature was lower, so the residence time was higher, 45 or nearly 46 seconds in this second problem. And we can also see that the Gazpacho volume flow was lower, 3.6 times lower in problem 2, because it aimed at reducing or decreasing the steam volume flow, and so this Gazpacho flow was also lower. We can also see here that in the first optimization problem, we aimed at increasing or maximizing the quality of the product. The vitamin C retention was, 92% of the initial vitamin C content was retained. And in the second case, the second problem, or the problem 2, which aimed at reducing or decreasing the steam consumption ratio, this ratio was very low, 6.45. But also we can see that in the first optimization problem, this steam ratio is slightly higher, and the same with respect the vitamin C retention in the second optimization problem. That was not as high as here, but around 90.5% of the initial vitamin C content was retained. So here we can see an example about how the mathematical models are very useful in order to optimize the process like this pasteurization process. And we can also see that in this example, although we have optimized the process under 2 points of view, some values are very similar as regards the quality of the product and also the steam consumption. So thanks a lot, and if you have any question, please do not hesitate to contact us. Thank you.